Well, in that last podcast, Mr. Sams, we learned about breaking things up.
We did.
And heating them up.
Yeah. Now let's do some math.
We should do some math. Everybody get your calculator out because you're going to do some mathematics. We did that all without math last time.
Yep.
And now we got to teach you the math.
Yep.
You say, there's math in science? Yeah, okay. Hey, before we do that, though, important thing, the graph. Have we seen this before?
I think we have.
Yeah, but we've got to add some more to it.
Yep.
So
let's put the equations on there.
there's some equations. Okay, remember we said there's heated up and break it up.
Yeah.
All right, so actually when you do heated up, there's actually the heated up equation.
That you've already seen.
Yeah, and this is Q is equal to MC delta T. And the break it up equation is a new one. It is Q is equal to delta H, we've seen that, times N. Now we'll have to define what those N's are in just a minute. All right, so where's heated up, Mr. Sam?
Heated up is when there is a temperature increase, so
So that's
A, C, and E.
So during the heated up portions, I like to sometimes just do like a slash line. That means they're going up, right?
Yep.
And the break it up are the flat portions of the graph. So heated up, so this is going to be, you're going to use MC delta T here.
Mm-hmm.
During part B, you're going to do delta H times M. N. I'm not going to write the Q. The same thing, because that's always equals that.
Yep.
MC delta T here, delta H times N, and MC delta T. So you should copy this down, and you'll see how we use that as we do the math problem.
One thing, should we throw the units on here? Talk about what your units come out as, because you do have to do a little bit of a conversion.
Yeah, that's an important thing. Actually, let's break this out here. Okay. So let's just take a look at these, Mr. Sams, about what they are. So we've got Q equals MC delta T. So what's M stand for?
That's our mass.
So that's going to be in units of?
Grams.
C is the specific heat, and that's joules per gram degree Celsius. You might remember that the most common one that we work with is the specific heat of water, which is 4.18.
And that's liquid water, we should point out.
Yeah, that's true.
Because ice and steam have different specific heats than liquid water.
And delta T is the change in temperature.
So that'll be in degrees Celsius.
In degrees Celsius. Now, Q, when we get this, will give us a joule answer.
Yes.
All right, that's important. Okay. Now let's take a look at the break it up equation, which is Q equals delta. Delta H.
Oh, I see what you're doing. Yep.
Times N. All right. Now delta H. These are the ones we talked about in the previous podcast: the heat of fusion, the heat of solidification, etc.
And those are all kilojoules per mole.
So those are in kilojoules per mole. Okay, that's weird. And N is something we haven't seen before.
N is moles.
That's moles. That's the symbol for moles. So if you've got so many grams of something, you just convert it to moles.
Yeah.
So the Q is going to be in kilojoules. So what we're going to oftentimes do is going to add these numbers up.
Right, but
the two Qs.
You can't add a joule to a kilojoule.
Yeah, it's kind of like saying I got $5 and you got 2 cents. So do I have $7?
No.
I have $5.02,
right.
don't I? So you can't add in the same unit, or you have to add in the same units.
So we're going to have to either convert joules to kilojoules or convert kilojoules to joules.
I recommend that you convert everything to kilojoules.
Yep.
It's a little easier. The numbers tend to be smaller and easier to manage. Okay, let's do an example. Example 1.
Okay.
Okay, how much energy does it take to warm up 25 grams of water from 4.5 degrees to 56?
All right, can we throw that on the graph and kind of see where?
I think it's important to always start there. Now this is water. And so for water, if I'm at 4.5 degrees, that would be about right here.
Yep.
And I'm going to go to what temperature?
40, I don't remember. 56.7.
56. So 56, I'm going to go here to here. So guess what? I'm only going to go through, well, it's a heated up deal.
Right, so the only thing we have to do here is Q equals MC delta T.
This is an easy problem, Mr. Sams. So Q is equal to MC delta T. So the mass is
25 grams.
25 grams. Now this is water, so this is 4.18 joules per gram degrees Celsius times my change in temperature. Looks like 52.2.
I don't know. I'm just putting it in parentheses and punching it in.
It's 52.2.
5455 is our answer.
5,455 joules. And if I would just quickly convert that to kilojoules, that's 5.5 kilojoules.
Okay.
So that's not too bad. That's how much energy it takes to heat that water up.
Okay.
Okay, let's do that. That's not too bad.
All right.
All right, let's do example number 2. How much energy does it take to melt 56.7 grams of water at its freezing point?
Okay, so this...
All right, let's look at the graph.
Okay, let's do that.
So if I'm at its freezing point, it's still water, working with water.
That's B.
Well, I'm starting here. It's melted. It's frozen. Frozen ice. And I want to just melt it.
Right. So we don't have any temperature change.
So we're just going to use the break it up equation.
We're just going to break it up. So Q equals delta H times N.
So Q is equal to delta H. Now, actually, delta H
fusion
FUS times N.
Okay.
Now, we got to find what N is, though, because we have 56.7 grams of water.
So we're going to do a little conversion.
56.7 grams over 1. And this is water, so I'm not putting the... I'm going to say grams to 1 mole. This is just grams a molar. And it's water, of course, H2O, so that's 18 grams in a mole. So how many moles do I have?
That's 3.15 moles.
3.15 moles. Now, we didn't put this on the table, but you might remember the delta H fusion was 6 kilojoules per mole.
One significant figure.
6.02.
I think it's 6.01 or
I think it's
something like
0.01.
that.
Let's say 1. So you're just going to
later.
say 6.01 kilojoules per mole. Notice how I'm writing this so it's easier to see how things cancel. Times 3.15 moles. It's really over 1 if you think about it. The moles cancel and you get like
18.9 kilojoules.
18.9 kilojoules.
Okay.
That's pretty easy.
Yeah.
All right.
I have a hunch we're going to stick those two together next.
I have a thinking go right. All right, example 3. Let's make it hard.
All right.
How much does it take to warm up 25 grams of water from negative 20 to water at 60 degrees?
Grams of ice at negative 20, I guess it would be. All right, so let's
Well,
put that on the graph. Negative 20.
Negative 20, so I'm starting here at negative 20, so I'm X right there.
Okay, up to 60.
And we're going up to 60. 60 is here. Oh my gosh, I got 3 stages, Mr. Sams. I'm going to go from, I have to heat up the ice. I have to break up the ice, and I have to heat up the liquid water.
Yeah.
So we're going to have 3 problems, and we have to add them together.
Okay.
This is tricky. All right, when we're doing this problem, Mr. Sams, what I like to do is I like to kind of map it out. I need to first go from negative 20 degrees as a solid to 0 degrees as a solid.
Now, why'd you stop at 0?
Because if you look at my graph that we have right here, I need to stop whenever I get a change in the direction of the curve.
Okay.
So I have to stop at 0 because that's the temperature it stops at. And that is a heated up equation, so I'm going to say MC delta T. I'm not going to say the Q because that's what we're solving for.
Okay.
So the mass was 25 grams times the specific heat. Now, an important thing that's not on here.
Specific heat of ice.
The specific heat of ice is not the same as the specific heat of water.
Nope.
Now, we have this in your packet in a table, and I believe it's 2.09. So the specific heat of ice is 2.09 joules per gram degree Celsius, not 4.18, about half. In fact, exactly half, I guess. And the change in temperature from negative 20 to 20 is 20 degrees. So when we multiply that out, we get a total number of joules, 25 times 2.09 times 20, we get
1,045.
1,045 joules.
Now,
I'm going to quickly convert that to kilojoules because it's easier to add later on. So that'll be 1.0 kilojoules.
All right.
Then I'm going to go from 0 degrees as a solid to 0 degrees as a liquid. So if you
that's
go
a
back,
break it up.
That's a break it up. So if you go back here, I'm going just from here to here before the next bend takes place. And that's a break it up equation. So that's going to be delta H fusion times N. And that's going to be 25 grams. And you know what we didn't do? We need to
convert that into moles.
So if I have, I'll do it up here top here, 25 grams over 1, 18 grams in 1 mole. 1 point something, Mr. Sams.
8.35.
No, that's not.
Oh, right. That's the final answer. Sorry, getting ahead of myself. 1.39.
0.4 moles. So this is 1.4 moles.
I'm gonna get your 25 grams out of there.
Oh yeah, 1.4 moles times
6.01.
This is 6.01,
which is our delta H of fusion.
Kilojoules per mole. So times 1.4, was it like 8 or something?
8.35.
8.35. That's in kilojoules.
Right. Yeah.
So here we have this number and this number.
Okay.
But I'm not done yet.
Nope,
I still have to go from 20 degrees.
Nope, from 0 degrees.
Pardon me, from 0 degrees as a liquid to 60 degrees as a liquid. And that's going to be heated up, so MC delta T. So now we are going to use 25 grams. And this is liquid water, so I use the number I'm familiar with, 4.18 joules per gram degrees Celsius, times the change in temperature, which is 60 degrees from 0 to 60. And you get what, Mr.
6,270 joules.
6270 joules, which is 6.3 kilojoules. Now, I now need to add my kilojoule numbers up. These three numbers here. And what do you get, Mr. Sams?
15.7.
So the answer is the sum of them, so it would be 15.7 kilojoules. So that means to take 25 grams of water from here to here to here, it takes
15.7 kilojoules.
15.7 kilojoules. Okay?
All right.
I think we're good on that. Well, let's do example 4, I think of 6. All right. How much energy does it take to warm up 25 grams of water from negative 20 to steam at 150? Mr. Sam, this could be a big problem.
It is.
Yucky. Okay, we're starting at negative 20.
Let's not do example number 5 because.
So this problem, Mr. Sams, we're going to have to kind of map the whole thing out.
Yeah,
okay.
Let's do that.
So from negative 20, so we're starting here at negative 20. Well, we started here before, didn't we?
Yeah.
And we're going to go all the way up to
steam at 150.
Steam at 150. Oh my gosh. So we're going to have a 5-step problem, Mr. Sams. A, B, C, D, and E. So we're going to break it up 3 times? No.
No.
Heat it up 3 times and break it up
twice.
Twice, yeah. So I'm going to start with a blank screen. So I'm going to go from negative 20 degrees as a solid to 0 degrees as a solid. Now the reason I do that, of course, ladies and gentlemen, is I just need to go until I hit a curve in the curve.
Okay.
Yeah.
Let's map everything out before we do any math. So the next thing is we need to break up.
All right, I lost my place here.
There
we go. Sorry. Okay, then we're going to break it up.
Okay.
So we're going to do
solid to liquid at 0.
Solid to liquid is a 0. Okay, so we're going to go from 0 degrees as a solid to 0 degrees as a liquid.
Okay. Then we need to heat it up again.
So that's section C.
Yep, so we're going to go from 0 degrees liquid to 100 degree liquid.
So 0 degrees as a liquid to 100 degrees as a liquid.
Now those numbers would be different if we didn't have water.
Yeah.
We'd have the different freezing point and melting point of water, and you'll find that out when you get to your homework.
All right, part D. Now we're in part D, and in part D we're going to just boil the water. So we're going to go from a liquid to a gas.
At 100, yep.
So 100 degrees as a liquid to 100 degrees as a gas. And our last stage, going in the wrong direction, sorry folks, we're going to go from 100 degrees as a gas to 150 degrees
as a gas.
As a gas. So we're going to go from 100 degrees as a gas to 150 degrees as a gas. So now we can just plug out our equations in.
Yeah.
This is a heated up equation, so MC delta T, and actually this is too, MC delta T, MC delta T. Now this is a break it up, so this is delta H fuss times N, and this is delta H vape times M. So now we're going to just plug these in and we'll add them together.
Okay.
So this was 25 grams. Now this was ice. So remember the specific heat of ice. You'll have a table.
2.09.
Is 2.09. I don't think I'll put the units so I can have more space. And delta T is 20.
Because it goes from minus 20 to 0. That's 1045 joules.
1045 joules.
1045.
Which is 1.0 kilojoules.
Okay.
All right. This is delta H fusion, which was 6.01 times the moles. Now we did the moles in that last problem. 25 divided by 18.
Yeah, it was 1.39.
1.39, and this will give us a kilojoule answer, so it's 18.0.
No, I messed something up. I multiplied. Hang on.
Mr. Sams is...
I made a mistake. There we go. 34 point...
30?
Nope, I missed.
Mr. Sam!
I'm having problems. I can't use my calculator. It's like, there, 8.4.
Yeah, that sounds right. 8.4 kilojoules.
Yeah, it should have been the same as last time, which it is. Okay,
all right, now we're going to go from 0 to 100, and we're going to say M is, 25 grams, times the specific heat of ice, or water, liquid water is 4.18. Delta T, we're going all the way through the entire temperature, 100 degrees from 0 to 100.
10,450 joules.
That'll be joules.
10.5 kilojoules.
Which is 10.5 kilojoules. Remember, we're going to take this number, and this number, and we're going to add them up. We have 2 more to add, of course. The delta H vape was 40.7 or something, wasn't it, Mr. Sam?
I don't remember.
the heat of vaporization of water is?
Yeah, 40.7.
40.7. Again, this is on a table. Times actually this is M. That should be N. So 1.39.
1.39. So that's 56.6 kilojoules.
Wow, that's a lot.
That is a lot of energy.
Compared to all the rest of them.
Takes a lot of energy to boil.
And then 100 to 150 will do MC delta, so that'd be 25. Now, this is steam, and steam has a different specific heat. And so we're looking this up on a table.
1.7.
It's 1.7, and the change in temperature is 50 degrees.
2125.
2125
joules, so
which is
2.1 kilojoules.
2.1 kilojoules.
All right, so now we just add up the kilojoules.
Add up. I'll put boxes around the numbers we need to add up, and Mr. Sams will be fiercely adding them correctly this time.
Correctly, yes.
And so when we add all those box numbers up, the total energy it takes to take 25 grams from -20 all the way to 150 degrees.
78.6 kilojoules.
78.6 kilojoules. Interesting thing about that, Mr. Sams, is that almost all of the energy is being used to boil the water.
That's a lot to boil.
I'd say like 70% of it, or I don't know, I did math or whatever. But it takes a huge amount of energy to boil the water. Well, we'll think back to the last podcast where we had the water boiling. It takes a long time to break the bonds that holds the water molecules to the water molecules.
You're right, 72% of the energy.
72%. See, that's about right, 70%. So it takes a huge amount of energy. You'll have to do these steps. And these numbers, the 1.7, the 4.18, the 2.09, the 6.01, and the 40.7, those are all given on a table for you guys.
Yeah.
And actually, let me just do one more thing to show you there's another way to kind of look at this. The thing I want to talk about, ladies and gentlemen, is that there's when you're doing the delta H times M equation, you know, Q, actually, we said delta H times N. An alternate way is to say Q is delta H times N. Delta H times M, where M is the mass.
Right. So your delta H value is not going to be kilojoules per mole, it's going to be kilojoules per gram.
So for example, delta H fusion of ice in kilojoules per gram is 0.3, I think. Or something.
Yeah, 0.333.
So it's 0.333. That's kilojoules per gram. So sometimes you can work with grams when you're using your break it up equation.
Right.
And so it's not a big deal. It's just changing the M for mass for the N for moles.
Right.
It
and
changes
it's actually
this value.
And it saves you a step. You don't have to convert your grams into moles
Yeah, a
this
little
way
simpler,
either.
yeah. Or the delta H vaporization of water is 2.26 kilojoules per gram. Okay, and so then if I have the a break it up equation, I can say Q is equal to delta H VAP times M. So that's a funny looking M. You can then say 2.26 times, say your mass, let's say 25 grams, and you would get your kilojoules, and you would get
56.5, just like we did last time.
So if you look, yeah, it's the same number because we use 25 grams, and so it's the same number. It's just a different way to look at it. So sometimes it's easier to work in grams, and sometimes you might be working in moles. It doesn't really matter.
Just make sure you use the appropriate value of delta H based on the correct units.
Yeah. So that just makes a little bit easier.
Yep.
Okay. So, folks, Unit 6
The end.
is done. Unit 6 is done. We are very hot. This is one of the harder units you might discover it in, but hey, you're smart kids, and we know that you're smart, and that you can figure this out.
Gas laws next unit. Those are fun.
Gas laws, fun. Get to like blow up balloons and stuff.
Yeah.
We meet Wilson next chapter.
We do meet Wilson.
Yeah. So don't forget, you're going to meet Wilson next time. Yeah. Okay. We'll see you in class.